Alright, so I had class today. Just we went into there's like a simulator of a house in there. We put some gauges on the unit that was hooked up to the house and checked the levels of the refrigerant and if it was cooling. Then after that, we went and checked the ductwork and found out that we're gonna have to do redo the ductwork in this little simulator. That's what we're doing. Learning how to do this. Ripping out the ductwork and put new ones in. Man, I think I got something. Yeah, I'm just on my way home. I'm gonna get online for the online class, go through the book. I think we're about to do the midterm. Just ride around, going through. Yeah, I think I'm gonna stop by and get something for the wife. It's been a while since she had one of these drinks. So get something to eat. I'm hungry. I just left the house and went over to school without, all I got was just coffee and just headed to school. It started at 8. So now I'm just riding through. Burger King sounds real good right now. I haven't had Burger King in a while. And it makes one of these trucks I see them, it reminds me of the guys when I was working with them. And they give them a call. But, it's coming together. Being in the lab, it helps me. It's helping me, being in the lab. When you're online and he's going through the book, kind of like, okay, yeah, I'm gonna nod my head, but it really helped out, and I'm glad I can record it. I recorded it in the class, so I can always go back and look at it and kind of like replay it and like get more into it and understand it. It's helping me a lot. All right. Well.
Alright, so we had wired this fan up and wired our low voltage.
Like 90 something, 90, I feel like 95.
95?
Let me see, we're looking at what refrigerant that was on it.
I got a sore finger today because I got liquid refrigerant on it yesterday. Alright, now you want to purge that out and get the center hose on the gauges. We can rake the gauges and purge the hose out. Just crack the hose off.
And it's magnetized. It's not magnetized.
Alright, now hit the left button is tire. Punch that button. Alright, now. There you go. Yeah.
0.10.98654.321.
Alright, so let's crack our gauge open again. We came up to about 100 that time.
This one,
Yeah. We're going to feed liquid slowly because you're feeding liquid to the compressor right there, so feed it slow. Alright. When you get about a half a pound or a little better in there, stop and see what it's doing.
Okay.
Half pound.
Got a pound now.
Feed it slow. And you let the pressure fine until you're feeding it liquid. You got a pound 29 in it. And what it do? Come up to 110.
Now it's going down.
Let it settle a second. Watch you cross out on 110 PSI. Watch you begin to drop the head pressure a little bit. And our substance pressure a little bit. That's what I was hoping for. And you got 35 degree coil.
Yeah.
With
41.
41 degrees.
Right there.
He may be a little harder time seeing that. He's lower angle there. Let's see. I'm hitting something there. Pull the Freon out of my lines into the unit. That's gonna get an ounce or so extra charge. If I didn't overcharge it, I'm okay with getting an ounce extra. Now, y'all be careful when smaller, these new tracks, what you call them, new coils are really picky about charge. You get a smaller one of them systems, you throw an extra ounce or 2 inches, they do screwing up. But on a regular coil like this, you can throw a couple ounces in it, it ain't gonna hurt. These new micro channel coils, most people can see one from the show. The micro channel coils will not stand extra charge. Period. They are very picky, guys. So just crank both of your gauge valves open a little bit, let all the pressure go into the low side. Alright, now you can shut that down and take your high side line off the machine, big line, red line. Do a quick Alright, now you unhook the yellow line from the tank, pull the gauges up. Power it down and pull it back. I think it's one of all your tools nowadays are smart. Your tools nowadays are smart. They'll turn off after a while if you leave them alone. Dummy left me on, I was going to run the battery down and turn it shuts down. And yes, I've done that a few times with movers.
Go back sober.
Sorry?
Go back sober.
No,
Go
use
ahead and
that.
power it down. If you forget
Use
it,
that
go
one.
away to the other side. But, yeah.
It's not gonna pop in. You just gotta kind of balance it in, and then like.
You're on the right one, power button next to you.
Now you gotta open it. Now you gotta open it. And now push it all the way. Now you gotta hold it and tighten it.
Hold it, screw it.
And no overtime, because you can crack like how they did it. Remember, it was all bent. You can crack it just like that. So just like feel for it. You'll feel it like screw on.
Don't use the torque wrench, don't just make it tight.
You'll feel it stop. It stop.
Yeah, I feel it
Okay.
now.
You're good.
Use those in car tires. That's the same valve in car tires.
So let's close it and make sure that
You put them in your bicycle tires.
let's see, make sure that it's not on you, because sometimes they'll stay stuck on your stick.
You pull one out of your toolbox and put it in your car tires.
Not on you? No?
Nope.
Okay. Alright, go ahead and put that back on. Let's see.
I'm gonna open the valve and hit the single.
Yeah, see if it wasn't stuck to his stick. But sometimes it'll get stuck if you don't put it on all the way on. Like you didn't catch it, it'll get stuck on there.
Sticking out here. So what I would tend to do would be to get that trunk line in such a position that I don't have to have my ductwork getting stepped on. I would try to position that like that, so my ductwork's not getting stepped on. And I tell you what I would probably do, given what I have right here, is turn my trunk line. I don't know what this is outside of the roof or whatever, but I would probably turn my trunk line down this way and then run my runs off of it. We'll leave their trunk line alone, and there what we're gonna go ahead and do is get a little experience with this duct.
That's where they gotta chop them down.
Don't have a movie.
Get a spread 15-inch pipe. CFM on this run right here, and I know that I've already got a trunk line coming out here and going up the building. And this is going to start off in 10. Well, we'll figure that out in a minute too. We want an average of 100 CFMs out of these. We want to be able to deliver 100 CFMs each to these. So that means we've got to get 400 CFM out of this trunk line.
Yeah.
Okay? Gonna average 100 each. We got to be able to get 450 out of the trunk line so we can make sure we feed our ducks. All right, now we got to find equivalent length. We've got from here to here was about 15 feet. From here to here was about 10 feet. From here to here was about 5 feet and 5 feet. From here to here is about 8 feet. From here to here was, we're gonna call that 25, and then it was 24 wide. Yeah, we're gonna call that 24 feet. Time you get all your turns and everything in it for length. Now, we don't have any hard 90s in that because it's flex. I'm gonna count one at the boot, 90 degree. We have a takeoff right here that is a certain number of equivalent feet. Same thing over here. We've got a trunk line coming up here. And going to our runs. This gets to be fun. I'm trying to get enough in so that you get an understanding but not overcomplicated. For the time being, looking for equivalent feet, effective length. Okay, on page 776, you have an effective length worksheet. You got length of trunk, length of ducts. You got effective length. Let's see, where was that?
We're gonna enjoy the city. We'll get out there, we're gonna be running.
Here we go, on our, page 773, we got a duct system there, we got furnace, we got trunk line, we've got, they've got the CFM already. I don't like their, figure in there, it don't figure on the regular duct work like we're running. But let's just say that each one of these takeoffs, if I remember correctly, is about 15 feet of equivalent length. A 90-degree bend and round without turning vanes of any kind is gonna be about 15 feet. So to the effective length of each of these runs, and you figure it by the run, we got 5 feet over here, a 90-degree at 15 feet. We go up here to the first run, we're gonna say 5 feet there, and then actually about 10 feet up to this next run. So we're gonna say 10 feet there. Gonna end cap. So we're gonna say 15 for each of our takeoffs, and then we're gonna add 15 at the boot. Got 10 feet. All right, so let me see if I can explain what I've done. Between here and here, I got 10 feet to my first set of fittings. Every time I take off the run, we're gonna say, for purposes right now, that it's 15 feet of equivalent length. Okay? So we've got to figure our equivalent length of our ductwork. When you are figuring the longest runs, you figure everything between the plenum and that run. Does that make sense? Alright, so I've got 10 feet of ductwork, plus 15 feet for that, plus 25 feet a run, plus 15 for a 90 at the boot. We're gonna call that 15 for a 90 at the boot. So 10, 30, 40, 54 equivalent feet. 54, if I could write, feet, EL, effective length on that one. Alright, this one being a little shorter, we got 15 here, got 10, 15, 15, we're back to 48 equivalent feet. That makes sense? EL, effective length.
Can you go over that one more time?
Okay, I'm gonna do it. We're gonna do it for each run. Out here, we got 15 feet of trunk line out here, plus 15 for this elbow, plus 5 feet for that, plus 15 feet for the 90 degree at the register. Every time you make a hard 90, it's 15 feet of total effective length. That's an amount of air, because that air's got to make that turn. It's like it sees 15 feet of pipe trying to make that turn, effective length. That, turn your head this way. I'll say it again. A little bit more will catch as it goes through. Alright, so you're gonna go 10, 5 more, we're gonna go 15 feet, 15 feet, 15 feet, that's 45. Plus 15 feet. Yep, because it made that 90-degree bend. So these runs out here got an extra 90-degree bend in them. We got 10. Oh, let's just say 15 plus 15 plus 15 is 45 plus 15 there is 60 plus 5 feet. So that's actually a 65 foot equivalent length run. Because it's got more 90s and takeoffs, or more 90s in it. Same's true here. We're gonna add 10 more feet of duct to this one. So it's the same thing, but it's 75 equivalent feet, because what we did was added 10 more feet of duct here, trunk line. So it's 75 feet equivalent length. Out here, 5 feet plus 15 feet plus 5 feet, that's 25.
Hold on, where did we get the 10 foot to the 75 foot?
I'm sorry?
For the one that we got 75? How do we get 75?
Cause I took this one right here and added, the only thing different about it was there was 10 more feet of trunk line in it.
What about to get to the duct?
Well, that's what I did. That's what I'm telling you. I took this, all of this that I just added up, and the only difference in those two runs is that there was 10 more feet of trunk line in here.
Okay, I get it now.
So I added 10 feet of trunk line to it, so it's 75.
Okay.
Alright, so this one, over here, we got 5 feet of trunk, 5 feet of trunk, 15 feet of elbow, 15 feet here, 15 feet here, that's 45, 55, and, let's see, let me get on my, 45 plus 5 plus, 8 feet, no, that was about 5. So 45, 55, 60 feet on that one. Every time, you see what we did by adding this elbow on this trunk line right here?
That's 15 more feet.
These are got 48 and 54. You add one more elbow in the trunk line and we jumped up 10, 15, 20 more feet. We jumped up 15 more feet of equivalent length. That air had to go that much further, that much harder, just because it made one more turn. So how many turns do you want in your trunk line?
One.
I don't want any. How could I stop having turns in my trunk line?
Reduce them.
How about by repositioning the air handler? Could I reposition the air handler in the house and make
Oh
my
yeah,
trunk
put it in
line
the center.
different?
Yeah, in the center.
Yeah. Trunk line both ways? Now that's not always feasible. In this house right here, you put it out in the middle and you just killed your attic space.
Yeah.
And right now, the way that house is, you could have a little loft up there of some kind for whatever, and add a mini split, or if your unit's big enough, add a run to it. So you got so many considerations in this thing.
So would this be the best option for that diagram?
Which be the best option? What?
Yes.
The way it's done? It'd be a pretty decent option considering where the unit's set. One, we gotta get our trunk line out of the way. We wanna be able to use that space up there. It looks like a nice usable space. They put plywood on it. They expect to be able to use that space for storage or a room or something. So I wanna leave it open for them. Y'all gotta understand part of where I came from too. I had this contractor that I used to work with, and I will guarantee you, if there was an inch of space, he wanted it. You would not believe some of the crap that I have gone through with this guy trying to give him a few more inches of space here and there in the house with ductwork, and I mean some terrible reroutes on ductwork. So if you just drive me up the wall trying to route ductwork through places that I really didn't need to be running it sometimes, but buddy, we were gonna run it there to get it out of his space. And he always knew more about it than I did, so you know, we just go, well, he's a contractor, he's my customer. Well, the customer's always, yeah. I've never fired too many, but I came close a few times with him. I hope you don't have to fire a customer. Let's see, let me back up here. I never wrote my TEL on this one. So we got 15, 15, 15, plus 5 feet of duct, so it's another 15. Well, maybe that's what I wrote right there, 60 feet, equivalent length. This is a similar situation. We got 10 more feet of trunk in it, so we got 70 equivalent feet of length. Same situation, got 70 feet of length. So now our runs have 48, 54, 65, 75, 60, and 70 total equivalent feet of length. Does that make sense? You understand kind of how we got there? Oh. Now, we want to take our total equivalent feet. Now we got to go back through all these fun calculations. Determining the friction loss. Okay. Friction loss is expressed in units of inches of water column per 100 feet of duct. The friction rate for a duct system is the friction loss along the total effective length that results in a pressure drop equal to the available static pressure. Friction rate is calculated by the following formula. On page 772, are you there? Friction rate equals ASP in inches of water column, total effective length, times 100. Okay? So, our friction rate available static pressure.
Amazing.
So we're going to say that our machine has a 0.5
available static pressure.
Available static. You got to go back through all of these to figure that out. We're going to go back over here and find our blower speed in a minute. So we're going to go with 0.5 available static pressure. ASP 0.5. 0.5, am I doing that right? Yes. Go back through how we arrived at our ASP.
Going to like 1.3?
I'm sorry, it does. It goes down to 1.8 by the time you add all the things in there. 0.18 after we added all of our coils and filters. So we're going to go 0.18 is our available static pressure. Because it had to be the 0.5 that you figured on the factory fan chart minus the 0.32 that we figured out. So I'm sorry, our static pressure. So now we want to take our available static pressure divided by our total effective length times 100, so we got 0.18. Our total effective length of our whole duct system, let's see, total effective length, if I'm making sure that I know, yes. They didn't figure that like I did. Well, that's a very simple duct system. They didn't figure anything in for the. Let me make sure I do this right for you. Total effective length is the greatest effective length for a supply duct run in a system added to the greatest effective length for the return duct run. We have 15 feet total effective length of our return duct because it's only going through a grill. We've got the greatest one is 75, so we're gonna go with 100 total equivalent length. Which that's 1,000 ASP inches water column. The length is 100.
Hold on, can you show the work?
I'm working on it.
Okay.
Our longest run plus our return, because we have no return on our system. Well, let's just say that we wound up with 30 feet. Let's just say we wound up with 30 feet total equivalent on our return. Time it goes through a grill, goes through the box, goes into the unit. So our longest run is 75 plus our return, so that'd make it 105. Okay, that's our longest total equivalent length of our duct system. So that's our total equivalent. We're going to take that and divide 0.18 by 105. 0.18 is our static, divided by 105 equals 0.00017. We're going to multiply that times 100, and our total static that we're going to figure, our friction loss is going to be 0.17. And I put 8 after that. So our friction loss, figuring your friction loss. Now the friction rate is going to come over here on our chart. I'm skipping it, I'm sorry. Where'd that chart go? Here's that chart. Okay. That's a little high. We're gonna run with it. So our friction loss that we're gonna figure, so you're gonna go up here on your chart and go with 0.17. Right up the middle of the left side of your chart, see your friction loss? You ain't got a book. Where's your book? At the house. How you gonna do class without your book? Anybody else ain't got a book, share it with somebody.
So I got up to 0.17.
Okay.
Now that's the longest run plus the return.
75, you got up to 0.17, now go to your chart over here on the next page. Go up the left side of it and go to 0.17. Where's point two? There's 0.1. So 0.17 is gonna be somewhere below 0.2, you got it?
Yeah, about right here.
Okay. So, that is our friction loss. How many CFM do we want in this room out here? We wanted 110. So if you trace that across to friction loss at 110 CFM, what size duct do you come up with?
Is that 6 or 5? The 6?
Like around
6. Yeah.
Comes up with a 6.
Well, it's closer to
You
the
can
5.
just about get by with a 5.
You can get by with the 5.
I think you could get by with the, no, it's right,
It's right by the 5, man.
yeah,
It's right by the 5.
right by the 5.
Alright, if I don't know all of these things and I haven't figured the chart, I'm gonna go with 0.08. Or I'm sorry, 0.85 on my, when I figure duct work, this is just me. But we'll go stay with our 0.17.
It's closer, that's why. But every time we were doing the other day, we kept going over.
Okay,
yeah.
I mean,
Air volume.
yeah, the 5 be kind of like, either it is or it's not. Yeah. The 6 is like, it's definitely gonna make it.
It's over 5.
Okay, I'm getting y'all a trained duct calculator. I got you one coming. Alright, so, let's see this little key right here, this is key configuration. We're looking at 0.17, which is along here, and I'm gonna line up my air volume and CFM. If we said it was 0.17, then I want 100 over here, 110 over. Ratio means the closer to square it is, square is 1 to 1. It's 10 by 10. You can take that fraction and reduce it. Remember, reducing fractions by the least common denominator. Anybody remember LCD from grade school? So, 6 by, I'm sorry, wrong way. 18 by 6. Let's see. 3 6s is 18. So, 3 to 1. 3 to 1 aspect ratio. What did we say about when the aspect ratio's up? What does it cost?
Like a 16 by 8, that would be a 2 to 1 ratio.
16 by 8 is still a 3 to 1 ratio.
16 to 8? It's 2 to 1.
Oh, I'm sorry, 16 to 8. Yeah, it's 2 to 1, 3 to 1. You said 16 to 8. 16 to 8, 2 to 1 ratio. It depends on, you're gonna have some places where you've got to get in. You've got to get 6 inches to go through between beams. And it's just gonna happen. But what you're striving for is to keep that aspect ratio 1 to 1. What is the aspect ratio of a round pipe? 0. There it is right there, the aspect ratio. 0. Round pipe's the most efficient thing you can run. It'll carry more CFMs per the amount of metal it takes to make it. What does it cost you on a job if your aspect ratio is 3 to 1? Two things.
Time?
Time and material. Remember in there where it said aspect ratio, and we figured that piece of duct work and it cost you so much more metal. It was how much, some amount more metal because your aspect ratio was up. It took more metal to make a rectangle duct than it did a square duct. They'd carry the same amount of air. That sound familiar? All right, so back to our duct work. We said we could get by with a 5 on this one, but we're gonna go with 6 because we're gonna do something else on this. We're gonna put a damper in them. If they don't already have dampers, we're not gonna worry about it. Because this was in a open room, I'm gonna leave it a 6. Just gonna balance out that other one. But we saw that we can take a 6-inch round at 1.7 friction loss. Now y'all are gonna learn friction loss in here. You're gonna learn how to do it in here. You're gonna get to practice it in the field if you ever design duct work. Some of you may not ever practice it. Some of you may not ever practice friction loss. Why does it matter if you know and understand this stuff? Because you can look at a system with all of the things that you've learned in this book in mind, and you can know in your heart and know in your mind when you get done looking at that system that I have done the best service I can for them. You may say, ma'am, your system airflow is off by this much. I can do this, this, and this, and they may say, spend the money. You may write it up on a ticket and tell them that this, this, and this, and this, and they say, it works okay to me, fix the problem with a bad capacitor, and let it rip. Okay. You know, fix whatever, change it out. We're not gonna do the duct work, we'll just take a new system, whatever. But if you put a new system in and you don't figure in for all of this, and you don't tell that customer what's going on, and you don't document it, and you have them sign it or you documented it, what's gonna happen when it don't work right and they come back? You're gonna be in a sling. Cause you done messed up. If you ain't documented what's wrong with the duct system and they say all they want's a system and they won't spring for nothing else, at that point they're in the driver's seat of the decision making. You've recommended, they've made a decision. Will you ever walk away from a system like that? If you feel strongly about it and you got a pretty good idea this gonna come back on you, walk away from it. It ain't worth it. It ain't worth the headaches that it's gonna cause on the back end. That $2,000 profit may look good right now, but on the back end of it, you're gonna get there, you're gonna be in court with them or something, you know. This is why I want you to know this. You, as a service technician, as a business owner, as a heat and air guy that is an installer, if you understand this, you take it to the customer, your boss, whoever, you take it back to the office and run it through your load calculation program. You say, ma'am, this ain't gonna work. If they don't wanna work with you on fixing the problem, then you may wanna walk away from the job. You tell them, hey, I so-and-so up the street here, think of the best bottom feeder company you know and send them out to it. Send it to Reliable and let them have the headache. By the way, I call them unreliable heating and air. Walked on the house here a while back, two brand new systems. They had left the ductwork in the house and gutted the house, put the house back together, put new systems in it, and both of them were blowing air out the return. System swapped in the attic. They just put them in backwards. Both of them blowing air out the return. The guy calls me out. I said, well, I can take the system and turn them around, make it do what it needs to do. It's gonna cost you $1,500 a system for me to tear it out and put the air handler back in, right? I said, you've got recourse on Reliable. They put it in. It's been in a month or something, another 2 months. You just finished the house and found this out. Get on them. Sick them. But if you know this, you can walk up and figure that out and say, hey, now, so we averaged 100 CFM. We got 600 available. Will this system work? That work? That cool them in the summertime? Provided they put the insulation in the attic.
Close the roof off.
I put in the system one time. This lady called me. She said, I'm a middle-aged woman. I want it 65 degrees in my house and I want it today. I don't want to wait next week to get it 65 degrees in the house if I turn it down. That was figuratively because they were remodeling the house. I want it 65 degrees in my house. If I say 65, I don't want 68, I want 65. Okay. Yes, ma'am. So now you understand that in the mild weather, if the humidity's high in the house on this system and I make it 65 when it's 90 degrees outside, in the mild weather, you get a little moisture in the house, you get a little muggy because you got it 65, that I can't be responsible for that. Yes, sir, I understand that, all right. Sign here. I oversized it 1/2 ton. She called me back in about a month. They finished the house and she moved in. She said, I told you I wanted it 65 degrees in my house. I said, what is it? She said, 68. I said, 68, huh? Let's have a look at the system. I mean, we did it up right. We put air cleaners on it. We put surge arresters on it. We really just did everything. I threw everything I had at it. I said, it's gonna be one nice system. We put her in a system. I walked in the house, look, felt the air coming out. It's pretty cool. Feels pretty good. Walked around outside, blowing warm air off the top of the unit. Suction line's cool. Went up in the attic, was gonna put the thermometer in the air handler. Have I talked to y'all about checking out the air handler? Did I tell y'all about my Winthrop Manor in Rome where it had a 10-inch duct coming off the roof? They called me and said it was 80 degrees in the, no, it was 78 degrees in the room, and it was taking in 78 degree air and putting out 72 out the ductwork.
I think you said something.
I went up there and they found a 10-inch duct coming off the attic, pulling 120 degree air. My mix temperature in the return was 98, and it was still putting out 72 degree air. I said, the air handler's doing fine, we just got to close this duct off. Anyway, I went up, cause that's one of my favorite tools. Is take that wire, thermometer wire, drop it in the supply and return. If you got 2 of them, drop one in each and let it be sitting there and swap your meter back and forth, plug it into them and check it. So I went up in the attic to check, and it was doing 21 degrees across the coil. But what I discovered when I opened the attic doors, there wasn't a stitch of insulation in that attic. I came back down. I said, ma'am, I told you to put insulation in that attic up to R38. I said, there ain't a stitch of insulation in that attic. Before I could even finish closing my mouth, she was on the phone with the guy and said, there ain't no insulation. They said, get out here and put it in. I called her a few days later just to see what happened. I said, ma'am, is it 65 degrees in your house? She said, yes, sir, it is. So you can achieve a lot with it. But that leads back to my comment, if you insulate the attic, if this house is insulated properly, if this one is insulated at 800 square feet, if it's insulated anywhere near in the neighborhood halfway decent, a ton and a half will walk away with it. I experienced moisture myself on an apartment, 800 square feet, figured a ton and a half. I said, I'm building new apartments. It figures a ton and a half, 2 tons is better. Ton and a half system, I put a 2 ton, they don't make a ton and a half air handler, they only make a 2 ton air handler anyway. So I put a 2 ton air handler at it. I could get some 2 ton outdoor units for the same cost. I put them in there. I could get it 65 degrees in my house, but I had a problem. In mild weather, when the humidity was up, it was the walls that stay wet. The mildew. If you oversize it, you got problems. That's on my building that I own. As far as I know, them units are still there today, 3 years later. I want us to fix that trunk line.